Assalamualaikum and good day to everyone. This is a recorded lecture for chapter 3, part 2. The title is the assignment problems. And then what is the learning outcome of this topic? So basically at the end of this chapter, you can define the assignment problem and its importance, and then formulate the assignment problem as a linear programming model, solve the problem using a common method like Hungarian method, and then you can actually see or apply these problems in the real case scenario. So what is the definitions of assignments problems? So assignments problem is an optimizations problem used to assign tasks to agents. For example, we want to assign jobs to workers in the most efficient way, which is the goal is to minimize cost or to maximize the efficiencies by making the optimal one-to-one assignments. Means here, one job to one workers, for example. Okay, and then we can see that there are a few examples that can use assignment problem to solve it. For example, we want to assign employee to jobs. We want to assign machine to tasks in a factory. We want to assign sales people to territories. But at the end, it's one-to-one assignments. One employee, one job, one machine, one task, one salesperson to one territory. Okay, so these are the characteristics of assignments problem. Is one-to-one assignments, and then they will have cost matrix. For example, what are the costs involved, and then the objective is to minimize the total cost, or if we are using the price, selling price, for example, so we want to maximize the profit. Okay, so these are the steps of Hungarian method. We have 5 steps. Okay, first is to determine the smallest value at every row, and then you need to subtract all of the value in that row to that minimum point. And then we have a new table, and then we need to find the minimum column, minimum value at each column, and then you need to minus all of the value at each column with that minimum value. Okay, after that we need to cover all of the zeros, and then to make sure the number of so how to cover the zero is by using the vertical line or horizontal line. So at the end, you need to make sure the total number of lines must be equal to the total number of row or column. If not, you need to proceed to another step, which is you need to determine the minimum value at the cell that does not been covered with the lines. Okay, and then minus the value that uncovered with the minimum value. And then the last one is to add the minimum value with the value that has at the intersections line. Okay, so we will see that later on. So these are example. Okay, the truck leading delivery company in Malaysia. So they want to assign 4 trucks to 4 zones. So they want to determine the minimum cost representing this assignment problem. So what are the first step? First step is to determine the minimum value for each row. Okay, so we have 4 rows. So for each row, you need to look into row by row. First row, the minimum is 400. Second row, minimum is 450. Third row is 470. Fourth row is 430. So this is our minimum value for each row. So you need to minus the value at each row with that representing minimum value for each row. Okay, so we need to create another table after we minus. Okay, so we have this table, and then we need to create the new table after we have minus all of the value. Okay, you need to create this table. first. Okay, so now we label our truck. So let's say this is B, C, D. This is 1, 2, 3, and 4. First row minus with 400. So you will have a new value here. And then the new value here. This is 0. This is 210. The second row minus with 450. So this is 110. This is 30. This is 0. And then this is 80. The third row minus is 470. So this is 40. This is 20. This is 50. This is 0. The last one minus with 430, 0. So this is 110. This is 50. This is 70. So we got one new table here. Okay, so the next one is to determine the minimum value for each column. Okay, the next one is column. So first column, the minimum value is 0. Okay, minimum value is 0. Second column, the minimum value is 20. Third column, the minimum value is 0. You can choose any of the 0, doesn't matter. And then the fourth column is also 0. So for each column, you need to minus the value with the minimum one. Okay, so you will have a new table. New table. Where is it? You need to add a new table. Copy here. We paste here. Okay, so the first column minus with 0. So nothing changed. There's nothing changed because we've minus with 0. So the only column that have the changes is column 2 because we need to minus with 20. So this is 100. This is 10. This is 0. This is 90. Okay. Then the next step is to cover the 0. We need to cover the 0. Okay, so let's look at the row and column. Which row and column got a lot of 0? More than 1. So you can see the third row got 2 0 there. And then third column also got 2 0. And then there's one more. Whether you do vertical or horizontal doesn't matter. Okay, so now this is our answer. But we need to check whether the number of a line equal to the number of row. If yes, we can stop. But if no, we need to proceed. So right now, the number of line is equal to 3. Okay, we have 3 line. 1, 2, 3. So 3 line. So we have 4 row. So they are not equal. So means that this is not optimal yet. Okay, so we need to do another step. So we need to find lah. We need to find the uncovered value, which is the minimum value, 10. Okay, 10 is our minimum value. And then the 10, you need to minus the value that is uncovered with 10. Okay, so we need to create another table. We need to create another table. Okay, we need to create another table. This is changed already. So this is 10, 90, just, sorry, this is 20 just now, 100, 10, 0, 90. Okay, so now the 10 need to be minus. Okay, so the uncovered value we have here 1, 2, 3, 4, 5, 6. 6 uncovered value need to minus with 10. So 100 minus 10 is 19, 10 minus 10 is 0, 90 minus 10 is 80, 70 minus 10 is 60, 70 to 100. Okay, what else? So the next step is to find the intersection line here. So the cell at the intersection line, you need to add with the minimum value here. So 40 and 15, we need to add with 10. So we need to change this value, okay, by adding with 10. So this is 50, this is 60. Done, that part. Okay, so now we need to draw the line again. So see which is got a lot of 0. 1, 2, 3, 4. So now we already have 4 lines. Okay, 1, 2, 3, 4. So 4 line, 4 row, 4 column. So this table is optimal. So we can actually find our final answer. The final answer would be need to look for each row. Okay, to assign the track A, you need to see the zeros cell. Okay, so we have 0 cell here. So means that TA assigned to zone 3. And then for TB, since we have 2 0 at the zone 2 and zone 3, but right now zone 3 is already occupied. So the only left is zone 2. So we need to assign track B to zone 2. Okay, zone 3. So zone 3, we have 0 at zone 2 and 4. But we already assigned zone 2 to track B. So now we can only assign track C to zone 4. And then the last option would be track D. We need to assign to zone 1. Okay, so our optimal answer, track A assigned to zone 3. Track B assigned to zone 2. Track C assigned to zone 4. Track D assigned to zone 1. And then what is the cost involved? So the cost, you need to look back into the original table. So zone 3 for track A, zone B for track B, track B zone 2, track C zone D, zone 4, track D zone A. Okay, so that is our answer. So we have 400. This is 480. This is 470. And the last one is 430. So the sum of the cost is 1780. So this is our optimal answer for this assignment problem. Okay, done. So hopefully you understand how to do this. And then make sure you know the step. And that's all for this chapter. Thank you.